if some of you wants just to start a map without being, I mean, disturbed, but what I say, of course, they can do it. This is just an overview of, first of all, we will start with an overview of the project and then an overview of the units. To start with, this is the context CTX mosaic, which is serves you to give an idea of the word is context. You can see from here the valley, which is entering the J0 and the one exiting. So these are the main physiographic parameters that started to interest people about this crater. Then the map will be performed. You have the CTX mosaic on which you will perform the map, and also this very nice CTX DEM, which you can use if you want to perform sections or whatever you want to measure the thickness of, for example, of the data. I'm going to switch off the data because the DM, because it's a bit disturbing. But the map will be done only on this part of the area. Maybe before I created a bit of confusion with the detailed map. If some of you want to do something more, of course it's okay, but the exercise is simply of this area at this scale. Then we have Cassis data, and which are this one, and they have a resolution which is extremely good. Of course, Pier-Antoine, if you want to tell something, just jump in. Everybody, just jump in and tell whatever you want. Otherwise, I will move to CRISM. CRISM data. These are the level of the different level with the different RGB maps. This is the one. Maybe I should do like this.
Maybe, Monica, we can mention, you remember from the talk, Trent, that the data from HiRISE and CTX provided by USGS and the team are perfectly co-registered. And this is also a nice example of to see that actually data are not coming out of the box perfectly co-registered. And you can see that when you have really zoomed in, there may be some mismatch of a few tens of meters between CRISM and HiRISE, or even between the Murray mosaic and the team mosaic. So you should be aware when you're doing any mapping that, of course, these things can occur. And in case you need either, of course, control mosaic to start with, or you need to do georeferencing after the fact.
Yes, that's very important. Yes, that's a very important issue, because sometimes people are complaining where images are not perfectly matching, but this is the normal, unfortunately.
Yeah, if you remember the talk of Trent of Tuesday, he said that a large amount of work went into the co-registration of images at the 2-pixel level. But normally, if you're not paying attention to that, you always have mismatch here and there, and we have to live with it. Although, if not, you have to really go and create a control network and start co-registering everything very, very super finely.
There was a period in my life when I wanted to co-register everything by hand, and I mean, I was about to die just doing that. So it takes forever. Maybe before switching to CRISM, I could show how Cassis can be really useful to catch some boundaries, some transitions which are not so obvious only with CTX data. these images are really very nice. But back to Chrism, I tried not to create too much entropy in this project. On top, you have the RGB for the phyllosilicate map, so to say. Then we have the mafic. This is the mafic one. False IR. The carbonates. And this is the custom product we were mentioning before. And then we have the Arise mosaic, which is focused here around the deltaic feature. And with the associated DEM, and maybe you should play a little bit with it and go to see how much you can go into detail. This is, for example, a beautiful example of what probably are meandering channels cutting each other, point bars actually cutting each other. So with Irise, you can really see, maybe we could have a look at the difference of, you can really see almost the sedimentary succession, because you can really see the beds, the texture of the beds, and you can really go into the details. So this data will be useful to describe your unit, to try to better understand together also with Chrism data together, better enter in the science interpretation, and of course in the stratigraphic relations. If you don't mind, this morning I would prefer, I'm losing voice, I would prefer not to speak too much of stratigraphic relations, because I would like to see you to have a look at the images and come back to this issue in the afternoon, if you don't mind. Then you have the layer on the morphometry, but this one, I think it can stay there also with the transverse, because we will have a look at this in the afternoon. Now, let's think about the scale. For example, for me, this is a good scale for my screen, 1 to 50,000, but also 1 to 75,000 is not bad, even if maybe it's difficult to draw. 1 to 50,000 is better. It looks like you have more job to do, but actually you will be more precise and it will be easier to do that. So I would stay in a scale which is more or less this one. The first thing we should speak about are the contacts. Maybe I could use the annotation, but if I can find how it works, the annotation. Okay, by the way, I'm just using my mouse. I think you can see it. This is, okay, we have a boundary between two units. This is the unit C, this is unit D. The boundary is the same, this one, but you see, like, this part is very clear, very nicely expressed, and this part is maybe not as easy to, okay, you can clearly catch that the boundary is here, but it's not as easy as this one. So it might be a good idea to draw this as a boundary in which you are confident, so you are sure.
Monica, would you draw it at the top of the cliff or at the base? Because the top is easy, but surely there is
you are totally right. No, the base. You should, now I'm good. You know what? We could have a look at, I rise to, you know, to understand what you are speaking about. this part here is part of this unit. And you can clearly see that the transition here is easier to be identified than this one, because here we have a lot of aeolian features that covers this transition. So the boundary actually is this one. I hope you can find it, because I cannot find a way how to, because I'm stupid. Okay, now I think I can annotate, yes. But of course, I'm not working at CTS scale, so let's go back. I will never be able to use the annotation. Okay. Okay, now I can annotate. So it looks like I'm not able to annotate. By the way, the boundary is here at the base of the cliff, and this is a clear boundary. Instead, this one is a boundary which is a little bit uncertain because it's a little bit covered. This so I'm trying to see if I can annotate, but this boundary, which is not clear, we were mentioning because there is the cover by some aeolian bed forms. Something like this one, for example. Mapping aeolian bed forms is not trivial at all because, for example, there are few aeolian bed forms also here. It's something that you could waste your life mapping these kind of features, because if you go into the details, they are everywhere. So you have to decide at what limit you want to arrive to map them. For example, if you have a good extent, such as this one, this should be mapped like aeolian bed forms. This one is too small. If you start to map this one, you will never finish your map because it will be endless. Which is the rationale why you are mapping this one and not this one, because you want to keep your map consistent. You want to keep the map around this 1 to 50,000. So you want to map something which makes sense at this scale. If you draw something which is too small, you will totally lose this. It will be meaningless. In any case, what you want to show is clear that there are aeolian bed forms that accumulates very often, also here, for example, in the lower topographic part of your area. So this leads me also to maybe I had a sorry, I will lose half of my time in trying to understand how to use the annotation. Another point which is always a problem when you are mapping this kind of units is this mantling coverage. superficial units, which are basically a mixture of dust, weathering of the surface. There are basically two ways to map this unit. The easiest one is just to select the largest outcrop and create polygons with it, like this. I try again. In this case, for example, we have we can okay, identify this area which is particularly covered, and so on. Another way is to, I should add that I clearly see that this unit is simply covering this other unit. From some point of view, it is disturbing my observation, my representation, because I can clearly say that below this dust or whatever it is, my unit D is still present. So one solution is to not to map this as I was doing it here as a polygons, but to create another level, a separate level, only with the distribution of these superficial covers. Eventually, this can also be useful for the Euler bed forms. So create different layers that you can check and uncheck depending on what you want to show. This is a possibility in the representation. I don't want to say that you should use it now, because this is a little bit maybe advanced way, but to represent, but it is something that might be useful in your future. So create different layers, one for the bedrock, one for the superficial covers. And so you can, in certain moment, decide to uncheck the superficial cover and interpret whatever is below, so the bedrock. This is a possibility that you can exploit. Another thing that often create problems is related to craters. Craters are, then I will go back to the single units, but now I wanted just to make some general comments to different things. Craters are a lot, and mapping all of them, it's a nightmare, because you will never finish your map if you map all of them. So first of all, select which is the minimum size of a crater you want to keep. And so all of the craters that will be smaller than the size that you will decide, they will be just discarded. In this case, I think that something like 300 meters should be enough. I should be able to measure them. I think that this, for example, this is 270 meters, so maybe you can map until 200 meters because they are clearly visible, and they should be mapped. The smaller one, no, you just keep them. Otherwise, it takes too long without providing any important information. Let's remember that we are mapping here to provide a science constraint. Of course, if you would provide, if our goal would be to prepare a map for safety navigation, for example, all of the craters would be very important, but that's a different goal. We are providing a science context, not even into the details, so the smallest crater are basically useless in our map. Then sometimes people may argue, okay, I can map this crater as an area. No, but this, for example, let's go here. We have a crater. We can still see a crater rim. And also we can see, even at this scale, which is more or less the one we want to use for this map, we can see that there are aeolian bed forms inside. So if I map this like an area, I would lose the information of the aeolian bed form inside. So map the crest of the crater with one line. You can eventually distinguish when the crater, the crest of the crater rim is well preserved, and when the crest of the crater rim is not well preserved. This is something that you can do, but in any case, map it with a line in order to be able to map the crater rim, but also the aeolian bed forms, which is at the bottom. Okay, I think that these are the general issues. So maybe we can go and have a look at the unit one by one, if you agree. Okay, this is the crater rim. If we go closer, always trying to pay attention to stay more or less close to the scale we want to select. See here, the crater rim is covered by something which is not the crater rim unit. Also here, it is great covered. Maybe I can try to update it. Okay. You see, this is something that you can clearly map, even at your scale. And this is even going up to here. And this is not crater rim. This unit is, if you look, very similar to this one, if you agree. So this unit is very similar to this one, which is unit D. Then look at how these, let's call them bodies, are more resistant to and are standing tall respects to the surrounding terrain inside the crater. These should be distinguished, and they are probably still part of the let's call it basement, which form the crater rim. If I'm not clear, please tell me. This is unit, or maybe just to have a look at, even if it's outside the study area, it's interesting to have a look to this standing body here, which are here, and also somewhere you find something also inside your study area. One interesting point to address is, are these rocks something which was below this succession, then partially covered by this succession, like here? Or are they part of something which stays on top of this succession and which has been eroded elsewhere, and it was much more extensive before. This is a question to address during the mapping. Also, okay, I was about to say also using high-rise. You don't have high-rise here. Then this is unit B. Unit B, this one. One thing that you should map is, okay, unit B, but also this boundary here. What does it mean, this? Okay, this is, of course, the boundary of the unit B, but it also the fluvial incision. This unit has been eroded by fluvial incision here. So in this case, the boundary between the unit B and these bed forms here are marked by an erosional surface, which is important to map. Let's also have a look at the, sorry. Let's also have a look at high-rise. Maybe get rid of those drawings. Just also to play a little bit. This is unit B with these ridges here, these layers. And this is the erosion which affected this unit by the fluvial channel. And maybe we could also have a look at the carbonate. Again, there is a little bit of shift as I mentioned before, but if you do like this, you will understand immediately where the indication of carbonates have been recorded here. Another interesting thing is that unit B here stays clearly on top of the crater rim. I was mentioning, I don't want to speak about stratigraphy. In fact, I'm doing this, but still here it's almost covering entirely the crater rim. Do you think there is something to add on unit B, or?
Monica, if I can interrupt you.
Of course,
there
of
is
course.
a question about how to map better, how to keep the unit A and unit B in source contact, or to give them names like crater, rim. So it's about nomenclature.
This
We
is
are a little bit confused, but
okay. No, I understand very well that you're confused by this, because nomenclature is confusing. And it will be confusing until we will have a process of standardization of the names. On Earth, for example, all the names must come from a physical place. For example, if a unit is cropping out in correspondence of a village, it will take the name of that village. This is very convenient because there is no interpretation in the name. And which means that if in the future I will discuss this unit and I will change interpretation, or somebody else will change interpretation, the name will stay the same without problem. And this is something that probably we will develop some procedures, some formal procedure for the planets as well. But in this moment, we don't have it. Also because, try to imagine, data are coming each day. So now they are establishing new formations inside J0, which are described on the base of rover data. So, and now how to introduce the unit here? Shall we use CTX data? Shall we use high-rise data? It's complicated. So we have to live with this mess until we will find a way to try to put some order in this. So what I was suggesting today is a way to try to be as neutral as possible. So use interpretative term. This is a crater rim. I think there is no much discussion on that. We all agree. So it's a good idea to use an interpretative term in this case, because it doesn't create confusion. Actually, it avoids the creation of a new term, because this is also a problem. If new terms are created each time somebody prepare a map, it will become a mess in a while. So if you have a way to keep a name consistent, it is good. The same delta, okay, this is a feature which have been studied. There are a lot of papers on it, so the science interpretation is not under discussion. It's okay. In other cases, there was a lot of discussion about the nature of this unit. There is no consensus within the people who are working on these areas. So the name should be either descriptive or as neutral as possible. Since there are so many already descriptive terms which are not used for the very same units, so you have description with the similar description which is used for different units, and this creates confusion. I think that using names such as unit A, B, C, D, it's probably safer. It denotes probably also a lack of fantasy, but it's probably safer. I don't know if I addressed the point. Let's move to unit C, which is here, but also here. Unit C has, general textural characteristics, which are not so different from unit B. It's a little bit darker toned, maybe, but it's very rough. It's, now I use also high-rise. It's very fractured, like unit B. Okay, it is inside the crater, and this is another point. Should I map differently units which are similar but in a different geographical position? The answer should be no, because that would be already an interpretation. So that would imply that, in my opinion, this unit is different from this other unit because they were deposited in another position, which implies a different geological history, but they might have been deposited, for example, from like pyroclastic flows or something which would, some process which might have not been constrained by the geometry of the basin. So you can also look at these images, CTX and high rise, but also to the CRISM contest to see if you really agree into dividing this unit into different units, or maybe it's safer to map this unit as just a single one. They, in my opinion, are a little bit different in some aspects, but this is also something that you should decide after having a look. They also have a little bit different content in terms of hyperspectral data. So this is also something that you might take in account when you decide how to divide this unit. Then we have this unit D. I was mentioning this at the beginning, like here it's darker. The darkermost unit of our area stays clearly on top of unit C. It's a little bit less rough than the other unit, and it is characterized by this pyroxene contact. And it is present here, possibly sometimes here, in this, maybe I should annotate this. For example, this outcrop. Sorry, this drawing was really poorly made, but I mean, this is also evidence of this unit here. If we move to the fan unit, you will see, okay, in order to, in our purpose, for our mapping, you can map it just like one single feature, one single fan shape view. But if you want to go into more detail, you will see that it actually consists of many different things. I was showing you before that there are places, okay, this is something that you can observe only with high rise, so it's something that totally out of the scale of your map, but still you can see this feature here, which looks like point bars, which on top of which you observe these ridges. These ridges, which represent exhumed channel. This one maybe is more clear. And all of this succession, so we have the point bar, these channels, all of this succession is cut by this valley, which most probably suggests a water level drop, because also here there is an incision This valley goes up to there, suggesting that the water level within the lake was dropping, and so the channel has to cut through the previous deposits in order to reach the new base level. This is a nice small crevasse. But again, you don't have to map all of these particulars. You can if you want, but it's not our goal today. Maybe we can have a look at the frontal part of the lake, also to think about the possible relations between the frontal part, of the delta, also to think about the possible relations between the delta and unit D, and of course also unit C. This is a nice spot because we have 3 units intersecting each other. We have the fan, unit D, unit C. So which are the stratigraphic relations between this unit? This is something that it's important to try to figure out during the mapping exercise, so to say. So do you want to add something about the spectral data? Shall we tell something about this live? Before I lose completely the voice, or also on Cassis data, if you want to add something, we can do it now. Even if I must say it was also
okay, I think that you explained well the spectral data.
You are too good.
I think if they have any question, they can just put that in the chat.
Okay. I can maybe just to see if they can put in relation the spectral information with the morphology. I can do this and this, but again.
Yes, maybe I have something to add.
Okay.
So the spectral data, the Chris Mimes, is a bit noisy sometimes. You see that you have some stripes, some pixels that are alone, and so they do not indicate a specific mineralogy. They're just noise. So before you map anything based on spectral data, make sure that it actually correlates to some morphology. Okay, let's check this.
That's a very good point. Always use data in association with each other, because single evidences are. I tried during the first talk to stress the importance of understanding a geological context, and in order to understand the geological context, it is extremely important to associate data together. So associating morphological data and spectral data is a very powerful tool to constrain the interpretation together.
And yes, sorry.
No, sorry, I was interrupting you.
No, I just wanted to add that if you want to check the morphology, you can use the false infrared image.
Okay.
And because it's the same resolution as the other spectral data, and I mean, it's co-registered because it's the same data. So that's useful to check for morphologies.
That's very good suggestion.
And can you hear me, by the way?
Sorry?
Can you hear me?
Yes.
Yes.
Oh, great. I had some microphone issues. Yes, just if I can add also something for how to work between Cassis and between CTX, High-Rise, and Prism. Probably the best approach would be to, of course, use Prism to give a more genetic interpretation. I mean, a genetic information about the units, and then when you don't have that information, you can try to use more Cassis to distinguish the units that you have already have the genetic information. Because of course, it's going to be much more difficult to have such information with Cassis because it's not a hyperspectral camera, but it has the better resolution, so this can help you to distinguish between these units. I think this is probably the best approach. I don't know what you think, Monica.
Yeah, I fully agree. I must say this is, for example, there are some boundaries. For example, here, if I remember, without Cassis, it's not so clear. With Cassis, it becomes straightforward.
Yes, and then actually you see them with CTX, but it can help you to highlight immediately between different units, as you say.
Yeah. It's really beautiful. And I don't know, from going back to the, I would say, technical part of mapping, I don't know if I created too much confusion when I was mentioning the possibility to create two different layers for the bedrock and for the covers. So I don't know, maybe it's better to explain again that point, because maybe I have this habit to throw too much entropy to the system, and let's try to put this under control. There are different kinds of superficial covers. There can be, for example, this mantling unit or the aeolian bed forms. This unit, of course, must be reported in the map. Of course, are important in the map you are preparing, but at the same time are a little bit, between brackets, annoying because they cover the map you are looking at, and maybe they do not. For example, here you have an aeolian cover, but you can still guess which unit is this. So if you map this as aeolian bed form, this might result in like losing information on the extension of the unit B. This might be or might not be a problem. In this specific case, it's not a big deal because there are outcrops here that you can use, so it's not such a big deal. But sometimes it might be. Sometimes if you want to, for example, evaluate the extension of a certain area, because it's important to know, for example, if an area is only around the basin margin or inside and outside of that basin, you cannot, again, between brackets, cover it too much with these units that sometimes hidden and not your unit. So what you can do is to create a separate layer with a superficial cover. It's like to prepare two geological maps, one only with a superficial cover, and you can say also you can even create a code here is totally covering the U, for example. If I remember, for example, here you have aeolian bathrooms, which are totally covering what's below. Here you can guess what it's below. Somewhere else, they are just maybe patches. So you can even create your a sort of scale of the distribution of this unit. Needless to say, this in the map without the superficial cover, this boundary will need to be extremely dotted because, of course, it's covered by this superficial unit. But you will have the superficial unit each time you will keep your superficial unit layer open. If you don't want it, because in this moment you want to think about the distribution of the bedrock unit, you can just switch it off and look at the distribution of the bedrock units. Do you think it was clear, or it was useless entropy thrown in the system? So maybe it was acceptable. There is one thing I wanted to show you, even if it is outside of the map, because this is more science than mapping, because here this is the valley which will debouch in Jazio, and this is a beautiful crevasses place, which you see goes on top of unit B, and this will help you in the also in the determination of the stratigraphy between the different units. It looks also that the flux was going out from here, and it was able to excavate something, another channel in this direction. But okay, this is another evidence for stratigraphic reconstruction. But again, I didn't want to go too deep in this because I would like to leave you to think about. I suppose that you are mapping now, so while you are mapping, you are also thinking about the possible relations, so I don't want to spoil them. I think we went through all of the units. So if there are no specific questions on
Monica,
yeah.
maybe it was not asked, but this is something maybe some people are wondering, is which, if when they are mapping, they should keep mapping only with CTX, I mean having CTX only activated, and activate the other layers to just to provide more information, or if they could map over CRISM, for instance.
Okay, this is a good point. And I must say this is a very personal point also, because the risk of not using CTX while you're mapping is, okay, in the case of CRISM is also to switch a little bit because they are not perfectly co-registered, for example, here. If you map here, you will, your contact will result a little bit shifted respect to this one, and this is this might be a problem. In terms of high-rise, instead, mapping in high-rise, the risk is that after a while you will lose the sense of what you're doing, and you will be mapping this kind of particulars, because high-rise images are so beautiful, are so sharp, are so clear that you tend to lose, at least I tend to lose. This is very personal. When I should make this premise, when speaking about mapping, I am always very hesitant to give suggestions, because it's very personal. It's like the way you keep your field book in the field. It's you will not find two geologists with the same style, because it's extremely personal. So the baseline is that you will need to find your own way, because it's the only way that will work for you. Still, if you want to keep the other layers, the non-CTX layer open, remember these problems. For CRISM, the main deal is that you will risk to draw images, contacts in the wrong positions because they are shifted, the images are shifted. With high-rise, you will risk to be lifted in a parallel universe of beautiful details, and your map will be, the risk is to have a beautiful portion of the map which is totally non-consistent with the rest of the map. This is something that happened to me in the old times when there was no high-rise yet, but there was a limited coverage of mock narrow angle images. And I remember that I produced a map with fantastically detailed portion, and other parts of the study area without this kind of detail. So the map was wrong because it was not consistent. So at least at the beginning, the best way is to use the images to have a look at the characteristics of your unit. Then just switch it off and map on CTX. This is the safer way, the safest way not to have problems. Still, maybe you will develop a technique which is your personal one, which will allow you to work. For example, a tool might be, I'm speaking about high-rise, to fix the scale. You can, if you want, fix the scale 1 to 50,000 or 1 to 75,000, so you will not be forced or invited to change scale and lose the consistency of your map. This is a possibility, but I found it very risky, so I would stay on the CTX scale.
Sorry to interrupt you. Apparently the Q&A are disabled. Could somebody try to write a question to test?
I cannot, of course I cannot write questions.
We need attendees to try and do it. So if somebody can try to post, actually it works.
All right.
It works, actually, it works all right. Huh?
Okay.
Okay.
So if you think that there is something particular that should be revisited, or some aspect in general I was not thinking about, otherwise we can even move to stratigraphy if you like, but I would honestly, I would prefer to leave everybody to map without giving too many informations, because it's the only way to learn is to make exercise and not to be guided too much. Otherwise, you will not discover which doubt you can have. So or one thing we could do, but unfortunately my computer map is not working if somebody has problem, but I don't think so, because at this point of the school, I think that all the attendees are super expert with mapping. So I don't think we have to be to make a tutorial right now. One thing that you can also use during the mapping, sometimes you can have doubt about the geometry. Of course, you have the DEM, but you can also create quick profiles if you. Now I lost my, for some reason. With the I lost my plugin, so I cannot show you this. But okay, Riccardo did a beautiful explanation.
Okay, you want me to share the project and so we can have a look, or?
I don't know if can be of some use.
In any case, if anybody has problems with the question and answer, please use Discord. We can always, in case there is a glitch in Zoom, we can always record them there.
Okay.
Yeah, I see that some people has it disabled for some reason, and
yeah, it's strange because it's not consistent.
I will look into it now.
Okay, so if somebody has some questions, we can try to address them immediately now.
Okay, you can try to pose questions again, should be enabled.
Okay. Okay, it works. So if you have questions, we can maybe address those specific points without okay, let's see. No, this is the test. Of course, before entering in the phase of interpretation, no? Okay, we know some units, for example, the fun is, we told already it's straightforward, but we should try to create a scenario, no? But in order to do that, the only thing we have to do is, the first thing we have to do is to understand the stratigraphy. Otherwise, we could compare, in Italian we say we compare apples with pears, no? Something which is uncomparable. So first, let's focus on stratigraphy, and then we will try to reconstruct a scenario for this crater. I see a question. Okay, this maybe is for Beatrice. Can you read this? Maybe in the meantime, I will reply to this. Okay, first you go.
Okay, yes. So wait a second, I need to.
Okay, in the meantime, I can just reply to this question.
Yes, thank you.
Okay, the idea was to map to only the CTX mosaic, this one. But okay, if you feel that the area is too big, it's better to do something in detail, something done properly, instead of doing all the area just like that. So don't worry too much about the extension of the area, but more about the quality of what you're doing, to understand what you're doing. So, but nominally, yes, the idea was to map the CTX mosaic.
Yes, about the prism, some of you have asked why the two carbonate brush products are different. So I'll try to explain that. So the carbonate brush product, the one that you see yellow and magenta, is the usual carbonate brush product that is defined by the prism team, and it shows just areas where magnesium carbonate is really abundant. So just the yellow, and the magnesium carbonate is very abundant in that yellow area that you see in the prism. The other one from Horgan et al., it shows both carbonate and olivine. So it shows the relation between carbonate and olivine. So the white area that you see are the very carbonate rich, and they correspond to the yellow area in the other carbonate brush product. But the yellow area that you see instead in the Horgan et al. Brush product, they indicate areas where there is both some carbonate, but mainly olivine. And actually here they say both strong and carbonate detection and olivine detection, but I mean, carbonate detection are the strongest in the white area that Monica is showing now. The white area with, and yes, in this image, basically the white area is missing pixels because it's white, and so this we don't see them in the prism. Yeah, yes, that's exactly now where you. Yes.
Sorry, Beatrice, I was not reacting because I was reading the questions. And
okay.
Sorry.
So where you see now the hand, the small hand, and the GIS project, that is the very carbon-rich area, and it should be white in the prism brush product, but in the QGIS project, they're just missing pixels because of some settings of the image. Like this image actually has a white background, and to remove the white background, we also remove the white pixel.
But also here?
Yes.
Okay.
Also here, I think there's some very saturated pixels. So yeah, I don't know if I was clear, but I will also write in the chat the answer.
Yeah, but it's super clear, and this part is also super important. And
this is also, sorry, this is also an example of why those products are useful, but they are not 100% reliable on the, on the mineralogy, because this carbonate brush product from Horgan et al., like they show this brush product, but they also show the spectra that have extracted from these areas, and they actually see both carbonate, for example, in the yellow area, they see both carbonate and olivine signatures in the spectra. But instead, the color of the image are useful, but sometimes they can be confusing, because, for example, this area doesn't show up in the other carbonate. In the other carbonate brush product, yes, this one, it doesn't really show up. So they use different spectral parameters for these two images, and with some spectral parameters you can highlight some areas, with others you don't, and eventually you know the mineralogy looking at the spectra of the image. So don't rely only on these color maps. Okay.
Very good.
I will also write that in the chat.
Okay. In the meantime, I can address to this distinguish between delta and floodplain areas. Are you referring distinguish between? Are you considering this? I do not really understand the question. Whether for you floodplain is this one, or is this one, or are you referring to actually the basin of the so-called putative lake? I do not really understand. But I can see you something that this channel, I would not speak already, for example, floodplain is already interpretative. If you are considering this, for example, we are not so sure that these are sedimentary deposits. We are still, I mean, we are for now, we are just in the conditions of trying to put things in order stratigraphically. So this is the valley. This is for sure part of the delta. This is the margin of the delta for sure. This is just aeolian bed forms which limit it. For example, this is, for now, this is just unit B. I don't know if I really answered this question, but I didn't really, I'm not really sure I understood. I understood this. Maybe if you can write it again, in the meantime, I can reply to this. Would you map the crater rim as polygonal unit? I would map always crater rim as linear features, always. One possibility, but only in the case of a very detailed map, is to map the smallest craters as points. This is also a possibility. If you don't want to create very small circle lines, which can be disturbing, you can map them as points. But I would not map them as areas, because normally they are filled by some deposits, or they provide information about some units. So, for example, this crater, okay, this is but this one is a crater, but the rocks inside this crater are made of this unit. So I would use the linear feature. Instead, this is something I don't know if you already replied, Beatrice. Yes, I think so.
Yeah, I'm working on that.
Okay. And can demo an area with the unit? Well, I cannot do that, but
Monica, if you want, I can do it quickly before the break.
Okay, do you want to share? I stop sharing and I leave it to you. Just, I'm sorry, this is something my computer, it just doesn't work. And maybe in the meantime that you're, okay, there is no yet grain size analysis, it's too early. Okay.
Monica, can you see my desktop?
Yes, go.
So basically, that's the usual one. These are the chats, we get rid of them. That's a setup that Riccardo was showing yesterday and also Luca the days before. Essentially, it's a mappy setup, and it was just while Monica was talking, I was trying to follow some of the limits. And essentially, I was trying to follow the limit of the delta front within the unit. Is it D, this one, Monica?
Yes, just exactly. Yeah. Perfect.
And exactly before, I was trying to follow it along lines. They don't have to be the same line, actually, because, for example, let me just turn it off. In this case, in some cases, the limits are very sharp, like at the base of this apron and at the edge between this unit and this Aeolian covered unit. And in fact, you see that the bed from also going on top. But this was the discussion we had before, that it's easy to get the top of the scarp, but actually the scarp itself is made of the same unit, so you may want to do the bottom of it. And again, now I'm to zoom, now I'm 1 to 10K. So let me just go to 50K. And probably what I will do, I will go to 25K just to be able to draw it a bit better, but still then visualize it at 50K. I don't know, I can try to continue the mapping here of the limit. Obviously, that's not a super sharp contact because the base of the scarp is not that easy to pick. If, for example, here you see I'm just following the albedo, probably should turn on and off some of the other layers. I can maybe fix it later, but here I may lose this contact at some point, yeah? So I can put here, it's certainly contact, but yeah. And of course, I can progress through this in the areas that I can distinguish. Here, I may want to go this way probably to delimit this unit. I don't know if you agree with Riccardo, Monica.
Yeah, sure.
So let's try. Let's give it a try. I mean, it doesn't have to be really correct. Now we can always fix it, as Luca was showing. So here, really, now I do it at 50K almost, and here I really have to, make some interpolation. And I'm feeling a bit like I'm following the areas which is covered by Aeolians, which is highlighting this unit here. So this may be actually wrong, but let's just try to close it. Okay. I don't know, this is uncertain maybe. And we want to also put some indicator, correct? Since I don't trust my computer, just save it. And we put an indicator. How do we call it, Monica?
Sorry, I was replying on unit. This is Unit C, the one at the center.
Yeah.
Yeah. Sorry, I was replying to a question, and I'm not young as you, so I'm not multitasking.
Now let's see if it works. Sorry, I want to move the sharing. Yep. Okay, it works. Now
that's great.
Yeah, well, it's not so great because we want to put it a bit transparent. Okay. If you want to help ourselves, we can also label it as we go. Okay. Right. So that's it. Before the beginning, I was also trying to look at the other units here. Of course, that's the creator. These are the easy ones that you remember Caroline was mentioning already yesterday, that you may want to start from the easy things at some point. Because here, if you zoom out, things seems easier. You see the front of the delta, you see these outliers, which could have been further delta deposits that have been eroded away partially, and these are like the the mesas that are more or less distal bits of it. I don't know if Monica wants to say something about that. Same story here. And of course, there are these kind of the unit D, which is kind of from the tone and texture is quite well distinguished here, but then things are getting a bit trickier. But again, we can start from the simple things and just we are at 46K, yeah, and we just put down the limits that we can see. I mean, it's also important to, you see here I may make big mistake because here, for example, I'm just mapping the edge of the top scarp, and all this area here that I will show you in a moment with the pointer may well be the same unit. It is just on a slope, so to say, right? It's the difference between the top and the base of a unit. So we have to be ready to make changes. But let's say maybe this unit I could have moved it a bit here, but that's okay. And here probably at the base of it, I can put also a limit. It may well be that what I see here is the same over here, right? So this seems to be a C. Am I correct, Monica?
Perfect.
So let's try to make it a bit quick and dirty. Maybe we can just try to close it. We can always expand and merge, but we try to limit these other occurrences of C, which is kind of embedded in D. Correct me if I'm wrong, Monica.
No, it's.
I mean, again, it's a bit of a formal approach here that I'm applying, but
It's perfect.
it's not so perfect. On the east is a bit trickier, but
No,
Yeah,
but in any case, it's.
now
I think the procedure is clear.
Now, let me also put an indicator just in case. Here. How did we call it? This C, Monica?
See, yeah.
Now, sometimes when you do the mapping, it doesn't work because you didn't close them. And I'm not sure if I intersected properly. It seems I did it here and here. And that's one of the things, if you're doing the mapping too zoomed out, it may seem that it's closing, but it's not. Let's see. Yeah, so we closed it. For example, here before I was lazy, and I did this from very far away, and it didn't close. So of course, it's my fault, it's not Mappy's fault. Right? Now, I want also to anticipate a bit because we have just 5 minutes to what we can see at 2 o'clock or a bit later, because now we are mapping this area. Our, so to say, area of map nominal is the CPX mosaic. So you see the square. So here we are already zooming quite at some detail. For example, what we could look at the CTA scale and not at the RIs is the feeding channel. And here, of course, I can also start putting some limits. You know, sorry. You know, the thing is that sometimes when you map, it's a very relaxing process, can be. So sometimes you are going with the flow and you're mapping. Sometimes maybe you're fed up with the part because something else some other observation come up. So that's okay. I mean, as long as you're saving your path and you're taking your notes, this can something that you can follow up later. For example, here I'm trying to follow this, and this is not really easy because there is a lot of organ material. So that's the mantling problem that Monica was mentioning before. So at some point, I'm getting not confident anymore, so I just stop it. I'm very conservative, so I put a lot of uncertain, but it's pretty certain actually. This maybe it's just not a sharp contact. And then, of course, I can move on in this direction. Now, just to anticipate what we're going to see in the afternoon. Obviously, we know where perseverance landed, right? And Fred was very nicely showing it. And we also know where perseverance is headed. because obviously the in-situ observation and the materials from delta itself are key. So we have been around landing more or less at the edge between unit C and D. Please correct me, Monica, if I'm wrong. And then we have been more or less going with the edge of it, then crossing the boundary, and then essentially staying in D, and then moving into the delta material. And then you remember, sometimes you saw on Twitter, I think also Gwenel will show it probably later. You remember these kind of rounded boulders that were taken by the mast cam or super cam? Well, actually, if I'm not wrong, these are here in some channels embedded in this sculpt. But regardless, that's effectively the path that was taken. And after the break, we will look at it and we'll look a bit of the data similar to what you saw on the moon. And basically, here is a kind of a post-mortem of the traverse, because we know it already, but we will be able to see why possibly the team went to a certain path from the, so to say, safety and trafficability point of view. And also what you can do in your mapping exercise, you can try and figure out a possible path that maybe is touching more units. You remember what was mentioned by Fred at the beginning, that in your path, there are many things that you put together. You put together the science, you put together the safety, but safety rules, because otherwise there is no science, but still you want to maximize the science, which means that you want to maximize, for example, the age range of the units, the nature of the sediments, and so on and so forth. We are almost finished. I don't know if this helps, but basically the workflow is not so much different from the one of the moon, but obviously here things are trickier. First of all, we have most data, so in a way you're getting a bit flooded. But even if we try to get rid of some of the data and just saying with the visible panchromatic imagery, you see that is not that obvious. For example, the limit within units, and there is also a lot of erosional effects that are not necessarily lithologic. Well, they are indirectly also lithologic, but there is a lot of morphology on top of, so to say, the lithology. And mapping this, of course, gets trickier. So that's why probably it's good to start with the easier one and trying to look, as you saw yesterday on the moon, at the stratigraphic relationship between the different units. And this is, of course, very good when it comes to high rise, because you can see easier what is on top and what is below than with the CTX at detail. For example, how this material is on top versus embayment of units, because obviously you saw it also on the moon. I mean, a central peak is on top, but then it's covered by the materials on the sides. Okay, I don't know if this helps.
I definitely think so.
Okay, then I will say that we can make a break with it. Let me just save my ticks.
Angelo, can you also show again how to put the label on the...
Sorry, I was in Final Map. You go on Properties. You go on Labels, and then, of course, you have to choose single labels or rule-based, but we'll keep it simple with single labels. And then you have to choose what do you label with, the feature ID or the unit name, and in our case, the unit name. For example, I can see that in the source indicators, you see I have some null. And probably this null is the crater. Let me see. Let me see if that's the trick. No, wrong. That was the other one. So it's always better to zoom to feature, you see. Zoom to layer, first of all. Then open it to the table. In this case, I'm not sure what it is, so I just have to edit and remove it. I will give it a name later. I don't have to do everything now. And this will call crater. Okay. Let's see. Yeah, right. Okay. So this guy is still like all other values. So we have to figure it out. Like probably is an outlier of these things can be discussed. Okay. Anything else you want to bring up? If not, I save my project.